Hello everyone. So this video would not be a general organic chemistry practice video per se, but this would be an informative video where I'll be talking about a few common reducing agents used in organic chemistry. So let's see the first one. So this is NaBH4. So all of us know it as sodium borohydride. So this is actually a pretty mild reducing agent, and the preferred solvents that we can use sodium borohydride is in ethanol, aqueous ethanol. So water can also be present, 15% NaOH type of solution in water, diglyme, etc. And generally strong acids should be avoided when using NaBH4 because they might quench the NaBH4, the hydride present there. Okay, so this NaBH4 actually reduces aldehydes to 1 degree alcohols or primary alcohols, and ketones to 2 degree alcohols or secondary alcohols. And the preferred way of working up this NaBH4 sodium hydride after the reaction is simply neutralizing the sodium borohydride by using dilute acids, and then extraction can be performed of the products via organic extraction, solvent extraction. Okay, so the second reducing agent that we have is lithium aluminum hydride. So this is actually a pretty strong reducing agent. It reduces almost all type of functional groups, and this lithium aluminum hydride should be handled very carefully, and reactions should be done in low temperature. Preferred solvents being ether, THF, which is tetrahydrofuran, and strong acids once again should be avoided, and alcohols and amines type of compounds in the solvent should also be avoided because they would be reduced, and halogenated compounds, not halogenated, it should be halogenated compounds should also be avoided. And similar to sodium borohydride, strong acids should be avoided. So as I said, this reduces aldehydes to 1 degree alcohols, this reduces ketones into 2 degree or secondary alcohols, this reduces the carboxylic acid groups if they are present, it reduces them to 1 degree or primary alcohols. If there are esters present, then there will be two mixtures of alcohols, that would be actually mixture of two alcohols should be present, reduced to. Nitriles are reduced to amines, not amides, it should be amines. So it might be primary amine or secondary amine depending on the nitriles. So nitriles are reduced to amines, and amides are also reduced into amines. So CONH2 are reduced to CH2NH2. Halides and different type of tosylates are actually reduced to alkanes. So the halides and tosylates are actually reduced to alkanes via hydride. The H comes in, the hydride comes in. Okay, the workup should be the careful addition of water to quench the excess lithium hydride that is present. There will be aluminum salts that will be formed, so those should be dissolved carefully, and then the extraction of the products should be performed. That is the organic solvent extraction should be performed. Okay, so the third that we have here is a similar reducing agent. This is basically lithium aluminum hydride with tertiary butoxy group in the presence of the 3H. So there is only one hydride group present. So this is a more selective type of reducing agent. So this actually provides only one hydride group. So this is also known as the lithium tri-T-butoxy aluminum hydride. The preferred solvents are same, ether and THF, and alcohols, amines should be avoided, halogenated compounds should be avoided, as well as strong acids should be avoided. And this is exactly similar to lithium aluminum hydride. Only in this case it is containing only one H. So let us see the reducing groups that can be performed by this type of selective reducing agents. So acid chlorides in this case are reduced to aldehydes. Of course, the reaction should be taking in place in low temperature. So it is similar in case of lithium aluminum hydride also. There also reaction should be in low temperature. So 3 degree amides are actually reduced to aldehydes, and that also the temperature is a low temperature reaction. Workup is completely similar to lithium aluminum hydride, where you have to add water carefully to quench the excess hydride and lithium aluminum hydride, and then the dissolution of the aluminum salts that are synthesized in the reaction, and then the products are extracted via solvent extraction. Okay, so let's go to the fourth one. This is also an aluminum reducing agent. So this is basically aluminum hydride having an isobutyl group in between. So there are two isobutyl groups. So this is also known as the diisobutyl aluminum hydride, and diisobutyl aluminum hydride is popularly known as DIBAL H, DIBAL-H. So this is what we call it in the laboratories and when we're learning organic chemistry. So the solvents that are preferred are similar. Toluene, THF. So in this case toluene can also be used, and THF, that is the ether solvent, is very good in handling such type of DIBAL H compounds. alcohols and amines should be avoided. Halogenated compounds once again should be avoided, and strong acids should be avoided, because all three of them actually react with such aluminum hydride type of reducing agents. So let us see what functional group it reduces. So it reduces acid chlorides into aldehydes, once again low temperature reaction, and 3-degree amides to aldehydes, once again low temperature reactions. So this is similar to the previous one. Okay, the workup procedure is also once again similar. There should be careful addition of water that should be performed to quench the excess dibalate, and then the aluminum salts that are formed should be dissolved, and once again products are extracted using organic extraction procedure, solvent extraction. Okay, so going into the fifth reducing agent, so this is also this is B2H6, also known as the diborane. So this is also a pretty interesting reducing agent, and this diborane is actually a mild reducing agent which can reduce functionalities of lithium aluminum hydride and NaBH4, but in a mild manner. Preferred solvents are ether, THF, and alkenes and alkynes should be avoided because the alkenes and alkynes can actually be reduced. So the solvent will also be reduced. Okay, so it reduces carboxylic acids to 1-degree alcohols, it reduces ketones to 1-degree alcohols or primary alcohols, nitriles are reduced to amines, so CN to CH2NH2, as you can understand. And the workup procedure is dilute acid or H2O2 can be used to neutralize it, and after that products should be extracted via solvent extraction, organic solvent extraction. Okay, so let's see the sixth reducing agent that we have here. So this is like hydrogen and metal catalysts. So this can be like many metal catalysts can be used, where there can be hydrogen platinum, hydrogen palladium, hydrogen ruthenium, and hydrogen nickel. And here what happens is actually the hydrogen is occluded, or occlusion of hydrogen happens, or adsorbed upon the metal surface, so metal catalyst surface, and from there it actually hydrogenates or reduces its functional groups. Okay, so the reduction that it performs, firstly the solvents that are preferred in this compound is alcohols, ethers, hydrocarbons can be used, hydrocarbons can be used, or carboxylic acids can also be used. Okay, so let us see the reduction that is performed. So as I said, alkene alkyne, it reduces to alkanes, nitro is reduces to amine, and NO2 to NH2. Imines are reduced to amines using such type of hydrogen metal catalysts. Aldehyde ketones actually are reduced to the corresponding alcohols, and it also might remove benzylic groups that are present because they are activated groups. And let us say when it is poisoned, like there is a catalytic poison present or an inhibitor is used, then acid chlorides can be converted to aldehydes. So this is like similar to the reaction of Rosenman reduction that we have heard about, hydrogen palladium BaSO4. So that actually converts RCOCl to RCHO, acid chlorides to aldehydes. Okay, so the workup procedure is filtration should be performed to remove the catalyst, and after that extract the products using solvent extraction. Okay, so the seventh that we have here are reactive metals like sodium, potassium, lithium that can be used. So solvents are basically liquid NH3, and ethers are also used as solvents. Alcohols are also used as solvents, or amines can also be used as solvents. So as we can actually know, as we have seen, alcohols or amines can be used as co-solvents. So as we know that sodium liquid NH3 is actually a name reaction, which is the BARC reduction. Sodium ethanol is actually a name reaction which is known as the Beauvoir-Blanc reduction. So both of these name reactions are they present in such reagents that has been used. These are all reduction name reactions. You can check it out in any standard book of organic chemistry. This reduces alkynes into alkenes, and ketones to 2-degree alcohols. Conjugated pi systems are reduced. So similarly, like let us say that you have got a conjugated pi system, like there is an aromatic ring. So the aromatic ring would be reduced. Let us say that you have got dienes or enones, and they would be reduced because these are actually pi systems. And it generally cleaves carbon halogen bond, and also the benzylic groups are also cleaved. The workup procedure is this type of reactive metal should be quenched with aqueous NH4Cl, and careful addition should be performed, and ultimately the product would be extracted via organic solvent extraction. So let us see the eighth one. The reducing agents are magnesium, aluminium, zinc, or iron can be used. Solvents like water, alcohols can also be used as solvents. Acetic acid, dilute mineral acids like HCl can also be used as solvents in these type of reducing agents. So as you have seen that zinc HCl is a good reducing agent. Zinc amyl HCl is used in Clemmensen reduction. So let us see it reduces, how it reduces. So it cleaves activated substituents nitro is reduced to amines, and C double bond O is reduced to CH2. So as I said, the C double bond O to CH2 is a name reaction which is known as the Clemmensen reduction. So Clemmensen reduction is performed by using zinc amalgam, zinc in mercury amalgam, and dilute HCl. Yeah, so thank you for listening to this informative video. Subscribe and of course follow for more such videos. And as I always say, that organic chemistry is a easy subject if you practice well and work hard. Thank you.